Are scientists really tracking something larger than Jupiter near Earth's orbit right now? Because if that sounds impossible, good, this story only gets stranger when you find out the part that is true. If mysteries like this pull you in, hit like, subscribe, and share this with one curious friend, because what looks like a giant threat is actually a lesson in how the universe fools our eyes. At first glance, the headline sounds like the start of a disaster movie. An object larger than Jupiter, near Earth's orbit, scientists investigating. It feels like the kind of sentence that makes people stop scrolling, sit up, and wonder if something massive is drifting toward us out of the dark. And honestly, that reaction makes sense. We are wired to pay attention to things that sound too big, too close, and too unknown. But this is exactly where the real story begins, because the truth is more beautiful than the panic. The object behind the headline is not a hidden planet. It is not an alien ship. It is not a dark world sneaking through the inner solar system. What scientists are watching is a comet called 220P McNaught, a small icy body that has suddenly exploded in brightness and grown a giant glowing cloud around itself. That cloud, called a coma, is what makes people say the object looks larger than Jupiter. Not the solid center, not the actual core, just the huge shell of gas and dust surrounding it, and that difference matters. Because if you only hear the phrase larger than Jupiter, your mind imagines a giant ball, something solid, something planet-sized, something with mass and danger. But that is not what is out there. The real solid nucleus of this comet is tiny compared with a planet. It is likely only around 1 or 2 kilometers across, maybe even smaller. That is closer to the size of a hill or a small town than the size of a giant world. You could never confuse the nucleus itself with Jupiter. The reason this comet is making headlines is that it recently threw off so much material that the thin cloud around it swelled to a vast size in space. That is one of the strangest things about comets. They can be physically small and visually enormous at the same time. A comet is basically a dirty ice ball, a frozen mix of dust, rock, and trapped gases left over from the early solar system. Most of the time, these objects stay faint, quiet, and easy to ignore. But when sunlight warms them, the ices inside begin to turn into gas. Pressure builds, cracks open, dust blasts outward, and suddenly, something that was almost invisible becomes a glowing shape spread across millions of kilometers. So yes, scientists are investigating. But not because Earth is in danger. They are investigating because 220P McNaught is behaving in a way that gets astronomers excited. It did not just brighten a little, it erupted. Then it did something even more interesting. It erupted again. That is why this story matters. Comet 220P McNaught was discovered on May 20th, 2004 by Australian astronomer Robert McNaught at Siding Spring Observatory. Back then it was faint, around magnitude 17.7, the kind of object ordinary skywatchers would never notice without serious equipment. This is a Jupiter family comet, which means its orbit has been shaped by Jupiter's gravity and it loops around the Sun every 5.5 years or so. Its path takes it from just beyond Mars at its closest out to the general region of Jupiter before it swings back inward again. In other words, it is not new, it is not unknown, it has a real orbit, a real history, and a real place in the solar system. For years, it behaved the way many small comets do. Quiet, predictable, easy to overlook. But then came late May and early June of 2026. Observers studying data from the Zwicky Transient Facility noticed something shocking. Between May 30th and May 31st, the comet suddenly brightened by about 7 magnitudes in just over 13 hours. That is not a small change. In practical terms, it was more than a 600-fold jump in brightness, and follow-up observations suggested it got even brighter, peaking near magnitude 8.2. That would mean it became up to about 8,000 times brighter than it had been just days earlier. Think about that for a second. A dim object buried in the background suddenly turns into something visible with binoculars. That is the kind of change that makes astronomers stop everything and look again. This kind of event is called an outburst. And comet outbursts are one of the most dramatic reminders that even small bodies in space can act like ticking pressure vessels. Sunlight does not just warm the outside of a comet. Over time, heat can work its way into the crust, reaching frozen gases hidden below the surface. Some of those gases, like carbon monoxide and carbon dioxide, turn into vapor at much lower temperatures than water ice. If a crack forms, or if a patch of surface collapses, or if part of the crust breaks apart, those trapped gases can rush out violently. They drag dust with them. That creates a giant fresh cloud around the nucleus, and sunlight reflecting off that cloud makes the comet appear much brighter. So when you hear that scientists are investigating, this is what they are investigating. What cracked? What vented? Did a chunk break off? Did the nucleus partly fragment? Did fresh ice get exposed after years of being hidden under a dusty crust? Those are the real questions. And soon after the first outburst, astronomers turned more powerful instruments toward the comet to find clues. The TRAPPIST-North telescope in Morocco studied the chemistry of the cloud around 220 p Mcnaught and found something interesting. The coma appeared enriched in diatomic carbon, known as C2, compared with cyanogen, or Cn. That matters because C2 is one of the reasons some comets show that eerie green color in photographs. Sunlight energizes those molecules, and they glow strongly in green wavelengths. The telescope team also reported a narrow and intense dust tail, and the pattern suggested the outburst may have involved a fragmentation event. In simple terms, part of the comet may have broken or shed material, exposing fresh volatile ice and feeding the outburst even more. Now here's where the story takes another turn. The comet reached perihelion, its closest point to the Sun, on June 14, 2026. At about 1.56 astronomical units, that is just outside Mars's orbit. After the first outburst, the comet began to fade. By mid-June, it was around magnitude 12, still brighter than before, but clearly calming down. Many stories would end there. A bright flare, a short burst of attention, and then a slow fade back into obscurity. But this one did not. On August 5th, 2026, 220 p Mcnaught erupted again. The second outburst was dramatic in its own right. The comet surged from roughly magnitude 14 to magnitude 7, another jump of around 600 times in brightness. That is incredibly unusual because one major outburst is already enough to make a comet notable. Two large outbursts during the same passage through the inner solar system, separated by only a couple of months, turns it into a real mystery. It suggests that the surface may still be unstable, that fresh material may still be getting exposed, or that the nucleus could be more fragile. This is where the larger than Jupiter idea starts to make emotional sense, even if it is easy to misunderstand. The nucleus is tiny, but the coma is not held together by gravity the way a planet is. It is just a cloud of gas and dust spreading through near vacuum. That means it can expand to absurd sizes. A comet can have a solid center smaller than a city and still wear a glowing envelope bigger than a planet. And we have seen something like this before. Back in 2007, Comet 17P, or Holmes, had one of the most famous outbursts in modern astronomy. It brightened by roughly 1 million times and became visible to the naked eye. Its expanding cloud eventually grew so large that the coma was measured as larger than the Sun in diameter. Let that sink in. A small comet nucleus created a cloud bigger than the Sun. Not because the comet itself had become a star-sized rock, but because gas and dust spread outward until the visible envelope reached that scale. That historical example is one reason scientists are watching 220 p Mcnaught so closely now. They know a modest little comet can create a truly giant appearance. This is one of the best lessons in astronomy. Size depends on what you mean. Do you mean the solid part? The bright part? The visible part? The dangerous part? The densest part? A coma can be enormous and still unbelievably thin. If you could somehow float through one, it would not feel like entering a planet. It would be more like drifting through an ultra-thin haze of dust and gas spread across a mind-breaking distance. Huge in dimension, tiny in density, spectacular in the sky, not a giant ball of solid doom. And that brings us to the most important question people always ask next. Is it dangerous? No, not based on the orbit we know. This comet does not come close to Earth in a collision sense, and the near-Earth's orbit phrase can be misleading if you hear it the wrong way. In astronomy, objects can cross the broad neighborhood of the inner solar system or lie in the general orbital zone of the planets without posing any serious risk. 220 Mcnaught reached perihelion at about 1.56 AAU from the Sun, which puts it just beyond Mars' orbit, not grazing Earth. Its Earth minimum orbit intersection distance is about 0.54 AU, around 81 million kilometers. That is not a near miss. That is a wide margin on human scales. Future approach data also show no dangerous encounter. So if it is not dangerous, why does it feel so gripping? Because this story presses on a deep human fear and a deep human wonder at the same time. We fear what is large, sudden, and unclear, but we are also drawn to it. The cosmos keeps doing this to us. It shows us something that sounds terrifying, then forces us to become more precise, more patient, and more honest about what we are seeing. A headline screams that a giant object is near Earth's orbit. Science replies, slow down. Define giant. Define near. Define object. Define risk. And once you do that, the real story becomes even better. Because what scientists are really seeing is a time capsule from the early solar system breaking open in real time. If you're enjoying this kind of clear, no-hype space storytelling, tap, like, subscribe, and share this video with someone who loves big questions more than big headlines. Comets are leftovers from the birth of the solar system more than 4.5 billion years ago. When the planets were forming, not every clump of material became a world. Some icy fragments remained small and stayed in cold outer regions for billions of years. Many comets preserve ancient material that has changed very little, so when a comet outbursts, it is not just putting on a show, it is releasing material that may have been sealed away, since before Earth fully finished forming. That is why astronomers care so much about chemistry. In the case of 220P McNaught, the enriched C2 signature is more than a pretty green glow. It is a clue. It tells researchers something about the material coming off the surface and how active regions of the comet may be evolving. Every burst, every fading curve, every dust tail, every spectral line helps scientists understand what this object is made of and how it is falling apart. And there's another reason astronomers love comets like this one: repetition. Jupiter family comets come back often enough that we can study them across multiple visits. They are not one-time guests from the far dark that vanish for thousands of years. They keep looping through the solar system. That means scientists can compare one return to another. Has the surface changed? Is the nucleus weakening? Are the outbursts becoming more frequent? Is the comet losing its accessible ice and moving toward dormancy? Or is it still hiding volatile pockets deep inside, waiting for the right moment to explode into view? That long-term view matters because comets do not stay young forever. Every pass near the sun changes them. They lose gas. They lose dust. Their surfaces crust over. Some become quieter with time. Others suddenly surprise us after years of calm, almost as if they have one last dramatic act stored away beneath the surface. 220P McNaught may be one of those objects that looks ordinary until stress builds in just the right place. And that unpredictability is exactly what makes comets so magnetic. Planets are majestic, but they are steady. Stars are brilliant, but they are far beyond our daily influence. Comets feel different. They feel alive in motion. Not alive in the biological sense, of course, but alive in behavior. They brighten, fade, split, flare, and grow tails. They respond to sunlight in visible, emotional ways. A comet is one of the few things that can seem to change before your eyes. That is why people have watched them with awe for thousands of years. Ancient cultures saw omens. Modern astronomers see physics. But the emotional core is not so different. A comet interrupts the normal order of the sky. It appears, transforms, and vanishes. It is temporary. That makes it powerful. And 208P McNaught has done exactly that in 2026. It went from a faint object known mostly to dedicated observers to one of the most talked about comets among skywatchers, because it refused to stay quiet. The first outburst was enough to get attention. The second made people ask whether a third could happen. That question matters because once a comet starts shedding material, the story is no longer simple. The first rupture may expose unstable layers beneath. A weak section may collapse again. A fragment may detach and vent on its own. Multiple active spots could awaken at different times. Scientists do not yet have a perfect model for why some comets have repeat outbursts in one apparition and others do not. So every new observation becomes valuable. This is one of the humbling things about space science. We can calculate orbits with incredible precision. We can tell you where a comet will be in the future, but we often cannot tell you exactly when it will suddenly erupt. The path may be predictable. The behavior is not. And that gap between orbit and behavior is where the suspense lives. You can imagine researchers checking images night after night, looking for changes in brightness, shape, and tail structure. A coma that stretches, a center that softens, a brightness estimate that runs a little high, a tail that sharpens. These are small clues, but together they tell a story of stress, release, and change happening tens of millions of kilometers away. It is also a reminder of how modern astronomy works. This is not just giant observatories making discoveries in isolation. It is a network. Survey systems scan the sky. Professionals publish alerts. Amateur astronomers confirm changes, image the comet, and track developments from around the world. One observer notices something strange. Another checks archived data. Another captures a tail. Another measures the coma. Then the global picture sharpens. That collaborative process is one of the quiet triumphs of science, and it turns an object like 220P McNaught into a shared event. Not shared because everyone can see it with the naked eye. In many places they cannot. Observing conditions matter. In June, it was a dawn object low in the east. Better seen with binoculars or a small telescope under dark skies. Moonlight could wash it out. Low altitude could make it difficult. Timing was narrow. But that almost adds to the experience. Comets are not handed to us. We go looking for them. We wake before sunrise. We wait for our eyes to adjust. We search for a soft patch of light that should not be there. That effort changes the feeling of the story, because then this is no longer just a headline on a screen. It becomes a real thing in the sky, a real traveler moving through real space, responding to real sunlight. And maybe that is part of why these stories hit so hard. They reconnect us to scale. Most of our daily lives happen inside tiny loops: rooms, streets, messages, deadlines, habits. Then suddenly, a comet smaller than a town throws a cloud across a region larger than Jupiter's diameter, and we are reminded that the universe works with scales our instincts were never built to handle. Small can look huge, huge can be thin, distance can be safe, brightness can be misleading. The sky keeps punishing simple thinking, and that is a gift, because it teaches us to replace fear with understanding, without losing wonder. That is the sweet spot. Not numb skepticism, not wild panic. Informed awe. And informed awe is exactly what this comet deserves. If you strip away the clickbait framing, what remains is incredible. A faint Jupiter family comet discovered in 2004, orbiting the Sun every 5.5 years, suddenly blasted out dust and gas, brightened by thousands of times, showed signs of unusual chemistry and possible fragmentation, faded, then erupted again in August. It is a real scientific event, not because it threatens us, but because it gives us a living laboratory for how comets evolve. So when someone says an object larger than Jupiter is near Earth's orbit, the best response is not to laugh and not to panic. The best response is to ask a better question. Larger, in what sense? That question is the difference between confusion and understanding. Because if you mean the visible cloud, yes, a comet can temporarily spread material across a region larger than a giant planet. If you mean the solid body, absolutely not. If you mean dangerous to Earth, no evidence says that. If you mean scientifically important, then yes, very much so. And notice what happened there. The story did not become less interesting once we became more accurate. It became more interesting. That is rare. Usually, hype collapses when facts arrive. But in astronomy, the facts often reveal a deeper kind of drama. The universe does not need exaggeration. It already knows how to surprise us. Quick pause before the final stretch. If this video made you rethink how headlines distort science, press like, subscribe for more deep space stories, and share it with the one person who always sends you wild space news at midnight. Now let's go even deeper. Because there is a philosophical side to this story that I think matters. When humans first looked up, they had no idea what comets were. They seemed to arrive without warning and leave without explanation. They broke the pattern of the stars. They felt personal. We know better now. We know they are icy remnants governed by gravity and warmed by sunlight. But our emotional reaction has not fully changed because comets still carry a strange message. They remind us that not everything is permanent. A comet's great moment is often brief. A tail grows and fades. A coma swells and thins. An invisible object becomes the center of attention, then slips back into darkness for years. There is something almost tragic about that, something beautiful too. A comet does not hold the stage for long. It burns emotionally without burning literally. It becomes unforgettable by being temporary. 220P McNaught is doing that right now. It is not one of the superstar comets everyone grows up hearing about. It was not supposed to dominate attention. It did not arrive with the fame of Halley. It earned attention by doing something strange. And that, to me, is one of the most human parts of astronomy. The sky is full of famous objects, but stories come from the quiet ones. A faint comet, a crack in the crust, a burst of trapped gas, a green coma, a second eruption, 100 telescopes turning, 1,000 people searching before dawn. That is not just data. That is a narrative written by physics. And maybe that is why people are so drawn to space stories. They give us mystery without fantasy. They give us scale without losing detail. Take this comet's nucleus, maybe 1 or 2 kilometers wide. On human terms, that is not much. But hidden inside is chemistry older than Earth. Pressure strong enough to launch dust and material to create a visible structure larger than a planet. That contrast is impossible to process. Tiny source, fast effect, quiet object, loud appearance, ancient ice, fresh drama, and all of it is real. That phrase matters more than ever now. All of it is real. Not the scary version, not the exaggerated version, the real version. The real version says a periodic comet underwent a major outburst in May 2026, brightening by up to 8,000 times. The real version says a second outburst happened on August 5th, sending it surging from magnitude 14 to 7. The real version says astronomers found signs of C2-rich gas and a strong dust tail. It is not hunting us, it is exposing itself to science. That may be the best sentence in the whole story. A comet outburst is the object revealing what it has been hiding. Fresh material reaches sunlight. Chemistry becomes measurable. Dust patterns become visible. Weaknesses in structure show themselves. It is as if the comet briefly stops being private. And for scientists, that is a gift. They wait, they watch, they build tools, they compare light, they measure change. Then, every so often, nature does the experiment for them. That is what 220P McNaught is doing. And the investigation is still unfolding. That part is important too. We do not always get instant answers. Sometimes the story stays alive. Scientists are still gathering observations. They're trying to understand the source of the second outburst. They are building the case. So the story is not just about what happened. It is about what happens next. Will the comet fade? Will the coma expand? Will another outburst happen before it retreats? Will follow-up work confirm fragmentation? Those open questions keep us checking. The universe sometimes rewards attention. Somewhere out there, a small ancient object is still drifting through space, carrying frozen memory. Sunlight reached it. Something gave way. Twice. And for a brief moment, that tiny body made itself look enormous. Not because it became a planet, not because it became a threat, but because even fragile things can create giant signatures. We often think size is the same as importance. It is not. A comet nucleus no bigger than a town can command the world. A thin cloud can look larger than Jupiter. A faint object can suddenly become unforgettable. The universe takes what seems small and reveals it. So, yes, scientists are investigating. They are investigating a real comet called 220P McNaught. They are investigating ancient material. They are investigating whether the nucleus cracked. And in doing so, they are reminding us that the sky is not static. The next time you hear that something impossible is happening above us, pause before you panic. Ask what it really is. Ask what exactly is large. Ask what the evidence says. Because sometimes the truth is not smaller than the rumor. Sometimes it is simply sharper and more unforgettable.